Welcome to InSyB. I will be talking about something a bit technical on in terms of data science and also conventional statistics in healthcare research and in the healthcare domain. I hope you'll enjoy my talk. And of course, if you have any questions, please feel free to ask, and I'll try to assist you in any way I can. Let me share my screen now, my presentation. Can you see my screen?
Yep, perfect, Prof.
Okay, may I start now or do you want
Yes, you
to?
can.
All right. I'm Sarinder Kaur. I'm from University of Malaya, and I'm actually working a lot on the health informatics research with mostly with the clinicians in the hospital attached to University of Malaya, which is University Malaya Medical Center. And today's talk is basically will highlight critical data analytics and visualization methods using fundamental conventional statistics and also machine learning on various healthcare data sets. So this talk is going to be very especially useful for medical professionals, health informatics researchers, students who are pursuing in postgrad research in health medicine or clinical informatics. As we all know, these two domains, machine learning or data analytics, and also the conventional statistics, have been used by many researchers in terms of analyzing various kind of data in the bioinformatics domain, particularly in domains related to big data and so on. But we see that a lot of research are being conducted using statistical analysis or conventional statistics since its inception in various fields. It is it's a known fact that professionals or even health informatics researchers or even medical practitioners are very comfortable using conventional statistics in their research. But here in this presentation, I would like to also highlight the importance of the other techniques in data analytics. A little bit of background of statistics and machine learning. As we all know, statistics has been there in the limelight over 50 years now. Okay, since early 17th or 18th centuries, and we have realized the importance of advanced statistics in medicine as a prominent topic. But later, of course, as the computing power became um, uh, very advanced, a lot of statistical analysis was prioritized, and a lot of advanced tools were being used by researchers or by data analysts. However, machine learning was introduced mostly around in 1950s, and it has recently advanced a lot into deep learning, and also it has formed the basis of artificial intelligence. Um, the evolution of conventional statistics and machine learning in health research has started way back in 17th, 18th century, and now if you look at the 19th century and 20th century, machine learning has gained a lot of popularity in research. And a little bit of actually, if you really put a lot of effort in trying to understand the fundamentals of these two areas or these two fields, it is highly overlapping. It is the way we perceive, the methods that we use are quite similar in both these areas. If you look at conventional statistics, for example, hypothesis testing, mostly t-test, ANOVA, regression, hazard ratio. These are the common practices or common methods which are being used in conventional statistics. But in machine learning, it's a little different. The pipeline or the methods are a little different. For example, we do a lot of model evaluation, variable importance, decision tree, classification, prediction, and analysis. So I will try to go a bit on the fundamental side, where I'll pick on the concepts of conventional statistics. For example, let me start with hypothesis testing. So, those of you who have been working on statistics for a long time, or you're familiar with the methods, you will know that hypothesis testing is actually making interpretation or doing interpretation of results by making assumptions. For example, hypothesis based on experimental data, and mostly um, methods like t-test and nova are used to interpret the results using significant difference. For example, in medical, for example, if you want to look at this breast conserving therapy or mastectomy promote better survival among breast cancer patients, it's an inferential question, and the answer is actually observable. So patients are considered the observation, whereas the treatment types and survival data are the independent variables which decide the inference. And this is a good example of a hypothesis where we are actually looking at the question and trying to understand or trying to answer the question using observation or using available data that we have. And this is widely used in healthcare research even now to analyze and make predictions on various diseases. And the another important aspect of conventional statistics is actually regression, where we have linear, non-linear, logistic regression. These are very popular methods used by statisticians to look into the relationship of dependent and independent variables, which are, dependent variables can be continuous, categorical, and so on. However, in machine learning, right, the concepts are slightly, the way we perceive it to be, is slightly different, but of course, the basis is quite similar with statistics, where we, in machine learning, for example, predictive analytics, which is a very, very important method used by computer scientists to do predictions, where it requires a reliable relationship between the observation, the patients, and the independent variables who are for example, the factors, right, affecting the model development. So the prediction models generate accuracy measures to determine the quality of the data to predict the final outcome using input data, using the observation, and of course the output data, which is basically the dependent variable. And the concept is, for example, in classification, we use the approach where we split the data set into training and testing. We train the data using a specific algorithm in machine learning, and also we test the remaining data set in the trained algorithms to predict the results accurately. And we do have research questions in machine learning as well, and we do use classification techniques to actually find out the prediction, or we do prediction based on classification or prediction based on the what you call that, the question. And another important method in machine learning is basically the representation learning, where we use a lot of representation that are interpretable for decision making. And in this kind of method, we use a lot of unlabeled training data in supervised or even in semi-supervised learning to to for feature selection, and also for decision tree to basically predict the outcomes of our interpretation. And we do a lot of representation learning for image recognition, especially for biomedical image based on predictions and so on. So in another method where reinforcement learning is basically to we make predictions based on a sequence. We have sequence of decisions, and we have an agent, which is a computer program, interacts with the environment and learn how to act within that environment. And for example, it provides it is very useful in various healthcare diagnosis and treatment regimes, where We have we have a prolonged and sequential procedure of a medical procedure, and we need to understand how to make certain decisions based on the data that we have. Um, and generative models are also becoming very popular these days, where we understand the mechanisms of variables to find a generative model and predict the outcome. And for example, in epidemiologists gather dietary related data, and basically we find the factors affecting the life expectancy to predict the effects of guiding people to change their diet. So how do we do this? Basically, we build generative models, or we call it causal inference, um, to make this kind of changes based on the data that we have. And this is very popular for improving the accuracy of medical diagnosis as well. And now, since we already know or understand the fundamentals of both machine learning and also conventional statistics, we also notice that there is a lot of difference, although it's both are equally important in data analytics or visualization, but there are certain things that are useful or suitable using statistics, or in other words, there are uh, models that we should build using machine learning, or well, later in the presentation I will actually explain the importance of these two methods in our data analytics, especially in bioinformatics and also health informatics. So we always notice that in statistics, the data is pretty much simple or clean. We have a very clean set of data that we use for statistics, where um, the research has prior literature about the topic of interest, and we have a good number of variables which is involved in the study, and which is relatively small, and the number of the observations is more significant than the number of variables. Um, we have a specific hypothesis normally in statistics, where we prioritize the type of data, for example, in a cohort study and so on. So it's a more structured way of analyzing data compared to machine learning, where we have complex data sets, heterogeneous data sources, and data can come from many online repositories, and it's multidimensional big data. Hence, the prediction analysis based on ML algorithms learn from the data. So it is very, very much reliant on the the source of the data, where if we have good data set, then of course our prediction of or classification will be of high accuracy. And in statistics, the visuals that we create normally, like the graphs that we have, or the output that we have in terms of plots and graphs, are quite basic compared to machine learning, where we can actually build domain specific, customized, inherently interpretable models results. Hence, in that way, it could be different. If you're looking at something more simple, you can build using basic statistics. But if you are looking at building a better, visuals or better prediction models, then of course you can explore the use of machine learning. And machine learning is basically, we use a lot of box algorithms that have the ability to cover subtle hidden patterns in a multimodal data set. And in statistics, of course, you don't need a very high end computational power. Okay. And it's easy to literally, it's quite easy to use statistics to do or to perform analytics. But in machine learning, it can be quite tricky, where we use a lot of high computational power, processing power. We need a lot of storage in ML algorithms, which of course we require to update our models or our algorithms, our software, with newer versions, and we need to update the coding and so on. And there's no proper guideline to or ways to explain the graphs for interpretation of final result. It requires sometimes a lot of validation for over prediction or overfitting data set. And automatically we need to provide required results and decisions automatically. We can also do more hybrid models to resolve the arising um, issues in data science for knowledge extraction, especially in healthcare. We need to look at various things or various issues. Alternatives to conventional statistics. So, what are the machine learning alternatives to conventional statistics? Actually, both can work hand in hand, and both are important, equally important, and both are actually quite similar in many ways. For example, in conventional statistics, we do a lot of, or in machine learning, we do a lot of imputation, data imputation. Uh, Sorry, in conventional statistics, we do a lot of imputation based on missing data. For example, if we have a missing data, how do we actually replace the missing data set? Okay, there are many ways to clean the data or to replace missing data. So in machine learning, sometimes it is not necessary to do that, but of course there are also ways and methods to look at imputations where we have algorithms such as mice, Amelia, Miss Forest. These are simple packages in R where automatically you can actually perform imputation on your data set. And model evaluation and effect size. So in conventional statistics, we always look into effect size to see if data is variable enough for analysis, or we call it residual error. Um, and the method we use is basically residual analysis. And we use a lot of R square and underfit model, good fit model, overfit model to look into effect size. Whereas in the model evaluation in machine learning, we determine the quality of data to be used for further analysis, where we use a very standard pipeline where we split data into training, testing data sets. We build models using algorithms, whatever algorithms that we feel comfortable or we think they are very useful. And of course, we look into accuracy, sensitivity, specificity. These are the uh, standard measures to look into how accurate the model is. And also, um, in um, in conventional statistics, we look into significant factors, but in machine learning we call it variable importance. So significant factors are basically we select important independent variables, which are the target, which affect the target or dependent variable. And it can be sometimes we have 20 or 30 factors, but we need to look at how important these variables are in terms of actually measuring the target variable. So in statistics, normally the practice is we run the analysis using all data, and we treat values, or we exclude missing values, or we use chi-square test or logistic regression to choose the significant variable. But in machine learning, this is a very important extension in data analytics, where we can actually select important variables which affect the target variable. We use a lot of variable importance methods or algorithms, which where we can use the best model which fits the data from model evaluation. We rank the selected important variables for further analysis. So variable importance actually is a very common practice in machine learning. And in medical research, we do a lot of survival analysis, because this is where our strength is, where we look at factors affecting the survival of patients, especially in studies like cancer studies and cancer research and so on. And in both machine learning and conventional statistics, I think survival analysis is quite popular, where it's just that the way we do, or the software you use is probably different, but the way or the method is quite similar, where we use the Kaplan-Meier to calculate the survival percentage. So here I'm going to show you a case study that we did in UMMC, where we do a prediction analysis on our breast cancer data set. And we use about 8,000 records between 1993 to 2017 to perform the prediction analysis. We use both conventional statistics and also machine learning. And we had 23 independent variables for and survival status to determine the most prognostic factors of for breast cancer survival. In We use both SPSS and R in our study to do conventional statistics and as well as machine learning. So my idea is actually to show the difference in the pipeline using both the methods or both the ways of analyzing data. Where we in conventional statistics we do hypothesis formation, data collection, analysis, and then finally report and visualization. However, in machine learning, we basically decide the target independent factors, we pre-process the data, we use different algorithms, and finally report and visualize the data. And as I mentioned earlier, the way we do analysis is different, where in statistics we look at effect size, but whereas machine learning we do model evaluation, and then so on. As you can see in the presentation, the method is slightly different, but at the end, the aim or the goal of our study is similar, to look at the uh, what do you call that, the survival of our patients based on clinical factors. So in machine learning, our methodology is very extensive, where we use supervised learning in our analysis, and the pipeline is very it's a generic pipeline for machine learning. However, we can use supervised learning we can use for our study or we acquire the data and we understand the data. As mentioned here, we had about 8,000 plus patient observations and number of attributes about 24. We perform data cleaning using R, and of course we cluster data based on certain clustering methods that is important in breast cancer. And we perform model. Second, we did the comparison using statistical analysis, also using machine learning, where we use RStudio for machine model evaluation. We build random forest model, decision tree, extreme boost, logistic regression, and we perform variable selection using random forest vserf and random forest explainer, and we build the decision tree and also the survival curve. Then we visualize our results using model evaluation. We build the plots uh, for looking for to look at the accuracy of our models. We perform variable selection, decision tree, survival. So we interpret and visualize our results using many different algorithms that are available in R programming, especially in machine learning. And of course, we work in very closely with the clinicians in the hospital to validate the results on important prognostic factors influencing the survival rate of breast cancer patients. Through we actually perform a lot of we actually discuss with the physicians in the hospital to see if our results are meaningful. And we perform imputation only for statistical analysis, because in the machine learning algorithms we use in our data could actually handle missing values very well. And we split our data into 30% and 70% for testing and training. In SPSS, if you look at the screen, we perform the significant factor analysis using basic tool in SPSS, where we know the significant, the p-value, which is the the important factors based on the p-value. This is what we could generate from SPSS. But if you look at the machine learning, we could actually rank the variables based on the algorithms that are available in machine learning. For example, we use packages like vserf and random forest explainer to rank our factors, our variables for our prediction. Hence, we know that, okay, which are the variables that are important for the prediction or for the analysis, for further analysis. So in this way, we can actually do a lot of dimensionality reduction, where we don't use all the variables in our analysis, but we can choose the variables based on the ranking done by the method used in this study. And we also build the survival, or we did survival analysis comparison using SPSS and R. So if you can see here, these are the survival plots that we built using both SPSS and R. They are quite similar in a way that, of course, the plots looks very similar, but of course the difference is in machine learning we can do a lot more cosmetics in our plots and try to make it look nicer and with more details in our plots compared to SPSS. So one thing that is important in both statistics and machine learning are the actually mathematical equations that are encapsulated to form algorithms. And these algorithms are then used to make prediction using supervised and unsupervised learning. Some of the widely used machine learning algorithms are mentioned here. I'm going to mention some of the very popular machine learning algorithms. For example, we start with decision tree. So in decision tree, of course, the method is we choose the features, we set conditions to split the data, we stop the splitting process to produce the final output, and so on. So it is an algorithm where we build an example of decision tree if with the data set that we had in our study, or the data set that I explained earlier. We build a decision tree based on the cancer stage classification using all the data, all 8,000 data set that we had, to look into the survival rate or survival of our patients based on certain factors. For example, the classification of cancer stage, total lymph nodes, positive lymph nodes, and so on. From here, the clinician can actually predict based on the decision or the tree that was created using our machine learning model. So of course, we look at the final output where we can see the percentage of survival for each of these parts, right? So if of course metastatic cancer, the survival is very, very low. Okay, this part, if you see on your right hand side, is the survival is very low compared to curable cancer or pre-cancer stage. Another important algorithm in machine learning is the random forest algorithm, which is considered the state of the art algorithm in medical informatics, because it has the ability to manage multivariate data where we have two dependent variables resulting in single outcome. And it's an improved version of decision tree, where it constructs more than one tree to select the best output. And extreme gradient boosting is another machine learning algorithm which also follows the principle of random forest, but with an added interpretation to predict the final outcome. Okay, I'm going to move on to the integration of conventional statistics with machine learning, where statistics, as we know, is a branch of mathematics consisting the techniques, mathematical techniques to analyze the visualized data. However, the machine learning is considered a branch of artificial intelligence that is actually composed of algorithms, both in supervised and also unsupervised learning. So, what I feel as a scientist who have worked in both conventional statistics and also machine learning is the importance of integration between these two fields, which actually could unlock and outline the key challenges in healthcare research. So, I feel that, of course, the foundation of all this is mathematics, where we use a lot of mathematical algorithms or mathematical formulas in both statistics and machine learning. But if we combine both these fields, we could actually do a lot of powerful analysis, or we could generate a lot of good outcomes in our predictions and in our hypothesis testing and so on. So this is especially important in all areas, especially healthcare, society, education, and research. And if you look at bioinformatics today, there's a lot of questions unanswered in diseases or in many of the areas like in proteomics, in genomics, transcriptomics. So if we know how to use the methods or algorithms in both statistics and machine learning, we could combine or integrate these methods to come up with good analysis or good outcome that could be very beneficial for the society and also healthcare in general. So, actually, what we need for the future is automated decision making, because, of course, we have a lot of data, and we have the healthcare providers actually make a lot of clinical decisions based on formal education, their experience over time in practice. That is why sometimes we see that, okay, it's better to go to a specialist who is experienced because of the many years of experience dealing with patients or dealing with a particular disease. So they tend to make better decisions, right? However, why not we change the mindset of this, rather than looking at the age of the clinician, we look at the tool that the clinician may use to interpret or to make certain decisions based on the data that has been there for years. Meaning that looking at a particular disease using data or years of data, 20, 30, or 40 years of data, maybe it could help in making decisions. I'm not saying that the clinicians can actually rely 100% on the AI or the algorithms to make decisions. But of course, it may help the clinicians to make better decisions by having certain automated decision making tools. However, experienced clinicians may not want to go through each step of the process. They rather make use their own intuition to make decisions instead of using certain tools and so on. But for new clinicians, I think we can actually help a lot in terms of coming up or producing automated decision making tools to enhance and standardize the clinical decisions. So the advantages of ML algorithms in medical informatics depends on the objectives of the research and the type of data used. We can build many automated decision making tools, but we need to know what kind of data that we have, also to how to handle a big data, and also whether or not these algorithms are able to generate visualizations which could be transformed automatically by clinicians as a guide. So the first thing is actually domain experts are still required. This is very important. We are not replacing the domain experts, or we can never replace them, although we have AI and so on. It's good to have them involved in our decision making and involved in building the models, also the tools. And the decision of clinicians on a particular patient's health condition plays an important role to give suggestions to the patients. uh, and this can be particularly enhanced by using automated decision support tools, because then we can use a standard procedure to prevent conflict in final decisions. So what I feel is basically the field of medicine relies a lot on knowledge discovery, understanding diseases associated with the growth of information or the data. Diagnosis, prognosis, drug development are key challenges in medicine, especially for complex diseases like cancer. Based on principle evidence-based medicine, decision making based on data and validation should be more agile. So this is what I feel that should be the future. And of course, the integration of conventional statistics and machine learning to clinical applications should be carefully adopted. We need collaborative efforts, which will include major stakeholders to influence the machine learning in medicine. Some of the work that my lab has done is we have built an automated machine learning tool by adopting the big data in the hospital. We built a database using MySQL, and then we use machine learning tools, especially supervised, unsupervised, and we visualize data. And finally, we came up with a decision support tool, which is an automated tool we built using Python to help the clinicians make decisions based on the data that is fetched by the database from the database. And this basically this tool can is able to retrieve data as the data is inputted, right, or the data is available, and also is able to select the analytics, the type of analysis that we want to do. We can also predict outcome, and we can visualize the outcomes, also finally download the report. So this kind of pipeline will be very helpful for the clinicians to make certain decisions. Next, the another important project that we did in the hospital is the natural language processing, both pathology and radiology reporting pipeline, where we moved from the conventional reporting pipeline to more automated, where we build an NLP algorithm to extract important variables from the report, and these reports are then used for secondary research, especially for predictive analytics. And in predictive analytics, of course, we use the machine learning pipeline to make predictions and come up with the decision-making tool. And these are the hardware we used. Finally, I feel that conventional statistics, machine learning, deep learning should be integrated, uh, which will contribute to medical diagnostics using multimodal data. And also, deep learning will assist clinicians in understanding the role of AI. And also, it can actually serve as a vehicle for the translation of modern biomedical data, including which includes EMR, okay, imaging, omics, sensor data, text. The list actually is too long, right? Because we have a lot of different kind of data, different kind of input that is at the moment. We have many sensors to collect data as well, and this all these are actually very good for the field of AI or machine learning. So in finally, my aim of doing this research or presenting this research is to highlight the importance of integration between machine learning and conventional statistics for added benefits, because both are equally important, and are best to be integrated to build powerful automated decision making tools. It's not limited to clinical, but also for bioinformatics data analysis. And finally, if we look at the kind of data, we can actually build AI enabled digital platform for modern cancer healthcare by even looking at public opinion or looking at sentiment analysis. We can actually get data from many areas to build research databases, to build predictions, to build automated tools. And finally, I think AI would be the future to integrate data in all these sources, and doctors and clinicians can then use mobile applications for to assist them in making proper diagnosis or coming up with the proper treatment for the patients. We have two publications from this research, from this presentation, that if you want to read more, you can actually go to our download our papers, and that's about it. Thank you very much. I hope you have uh, benefited from this talk, and I pass it back to the chair. Thank you very
Okay.
much.
Yep. Thank you very much, Prof. Sarinder. I really appreciate the talk. And I caught something that I think is very interesting, right? Because just now you said that, despite all these AI advances, ChatGPT, and all these guns coming up, right? They are there to actually add value to the healthcare providers rather than actually replacing them. I think that was such a beautiful phrase that you mentioned. And I think that a lot of times we tend to forget that. So thank you very much for reminding us. And I really love the talk, right? Like, you know, just reminding us of basic statistics and then after that building up all the way to your own research. I think that's brilliant. So I think while we're opening up we are going to open up sorry, well, we're going to open up to the floor for questions. But while we're waiting for people to type or people to verbally answer, I have a few questions that maybe I can start off with. So I think the first question is, just now I think you showed that you have data from UMMC patients and you were measuring breast cancer and the survival rate, right? So given such a sample size, I think there was about 2,000 patients that you guys measured. So was that model ever actually applied in UMMC? Yeah.
Okay, actually, we had about 8,000 patients,
Right. Okay. Sorry.
8,000 patient data,
Mm,
and we built a lot of automated tools based on this
mm,
data set.
right.
This actually, we are integrating this with our EMR, because we have
Mm,
our in-house EMR in PPUM
mm,
or UMMC,
mm,
which is called iPesakit. So we are actually
mm,
enhancing the EMR, not to just,
mm,
not just as a storage of data, but
mm,
also to help clinicians gather or make
mm,
decisions based on our analysis.
mm,
And yeah, basically all these are integrated in our
mm.
electronic medical records.
Mm, mm, mm. And just now you also mentioned that for the uh I mean for the older physicians, I don't know if that's the politically correct word. They tend to have a bit of a more pushback against the usage of decision AI that makes decision for them, whereas the younger ones they tend to be a bit more receptive. Do you know if there's any ethical concerns for the older physicians as to why they might not adopt such technology so readily?
Actually, there is it's basically human nature. I would consider that to be human nature, because um, humans, as you can see, the older generation, even in our daily life or even anything, they will tend to look at their experiences. It can be our parents, it can be doctors, it can be anyone with the experience, who are experienced in life. They tend to look make decisions based on their experiences rather than believing in the technology. However, because of the era now, the digital era, the newer ones or the younger generation are more inclined to use AI. Even if you look at, you can compare our parents, I mean, those who are in the middle age now, their parents and the kids. They will notice that the kids, anything they want to make decision, or they want to rely on, they want to, perhaps the first thing they do is they go to Google, or they use a mobile phone to help them make decisions. They tend to rely more on digital medium rather than the older generation. So it's just the mindset, I would say. It's nothing to do with the whether they don't trust or what. It's just the way they are. It's a human nature.
So it's more about technology savviness rather than actually trusting the algorithm behind. Is that what you're saying?
Also, yeah, of
Yeah.
course, they are brought up in different thoughts,
Different, right? Okay.
uh,
Yeah.
so
Okay. Yeah, I think we have a couple of questions. I have so many questions that I want to ask you because I think that is such a lovely talk, but I think we better pass it to the floor, or people's gonna start throwing rocks at me. So over here we have Rina. So, hello, Professor. Great talk. I'm curious to know, how do you propose to implement these generative models in hospitals, especially given the computationally intensive resources needed? Will these hospitals now have a separate server room sections, or maybe via cloud?
Okay, big hospitals like our, I'm talking about our in our in-house hospital, University Malaya Medical Center, which is our hospital attached to the university. So we do have a proper IT department which manages all these servers. We have our own servers, and we don't depend on cloud computing, but we manage our own servers. So we have a good computational power to help to manage this kind of systems, and a team, an IT team to manage them as well. So it depends actually if you are looking at the the, the kind of hospital. Of course, smaller ones may have this difficulty in maintaining their own servers. In that kind of environment or scenario, it's better to move to cloud. But also, it's better to have a private cloud because we are actually dealing with patient data, which is we have to look into the privacy and confidentiality of the data as well. So there are many factors actually involved in making certain decisions. It's best to look at the hospital policies in terms of um, building or managing the IT side of things.
So UMMC actually has its own high performing computer cluster
We have our own servers and all that manages
servers.
this.
Okay, all right. Next question from Akriti. Thank you for your talk, Prof. I wish to ask, how do you ensure generalized usage of computational biology tools which are based on limited data sets? Clinical data, spatially and temporally localized.
So AI is a very interesting field actually, because we do as we use the different kind of algorithms in AI or machine learning, there are algorithms that are more suitable for small data sets. So in if we don't have enough data set to perform our study or perform our analysis, then we need to focus on using the right tools, right algorithms that is suitable for limited data set. And also we can perform validation studies or validation based on existing literature or based on studies done in other areas as well. So in that way we can actually validate our results further to see if it's reliable enough to be used in clinical setup.
Okay, I have a question that was personally sent to me, and I that's also the question that I want to ask as well. So this question is about so, like, for example, UMMC has so much data, right? So that's why you guys can actually do uh the managed machine learning and so on. But what about for researchers that are outside of the hospital? Can they actually collaborate with staff from UMMC to actually work on projects like these? Because not every researchers have access to all this data, and I guess that these are all confidential patient data, right? So is there a way for researchers to work with UMMC?
Not directly, maybe through they can collaborate the researchers who are attached to the university,
Mhm, mhm.
because
Okay.
of course we need to work. We need to have some kind of MOA or MOU in
Mhm,
place before we actually work with people outside the
mhm,
campus.
mhm,
But it's not impossible. Of course, that is possible. I do have a lot of collaboration with universities in the UK
mhm,
and Canada as well.
mhm,
So I work with them, but of course, I do. I mean, through me, I can actually um, work in projects which
mhm,
involves data from the University Malay Medical Center. It's not that it's because I'm working here, but because for many years we have been
mhm.
actually building this research together.
Yeah.
Hence, there's some kind of trust that we have
Mhm,
built, that we will not violate the usage
mhm,
of the data. Because
mhm,
at the end of the day, we must understand that we are dealing with human records or human patient data, which is very highly very sensitive.
Yeah, I guess there's a lot more ethical and
Yeah.
confidential issues that we have to take into consideration of, right? All right, good. So I think thank you very much, Prof. Sarinder. Any questions from others? Calling once, calling twice, calling thrice. Nope. Okay. So I think Prof. Sarinder, thank you very much for your talk. I really appreciate it. Hope to catch you offline for a more detailed discussion. Thank you very much. Okay. So right now it is 10:51. Our next speaker will be Prof. Andrew Bin from India. So we will start his talk at 11 a.m. So meanwhile, again, take a break, digest. There's quite a lot of information from Prof. Kyoko and also from Prof. Sarinder. So I think let's take a break for a while, grab some coffee, and then let's be back at 11 for the talk at 11. Okay, so I'll see you there later.